Okay, welcome everyone. Thanks for coming this afternoon. I'm really pleased to introduce Amit Sheth, who's visiting us here today from University of South Carolina, the other USC, but now it's known as U of S. Oh. Just a different degree. But I've known Amit for many years. We work in very similar areas, knowledge graphs and other related things. And Amit's visiting ISI here today, and we're visiting campus tomorrow. He's giving two talks. The talk today is really focused on something he's been quite successful at, which is going to places and building large research groups in different areas. I mean, not just a research group, I mean, a whole sort of team of people. So at the University of South Carolina, he built an entire AI team there with how many faculty?
Now, the AI Institute itself has only 7 faculty.
7. So he's built,
but 50 people together. So
yeah, so he's built these large teams, people at various places. Before that, he was at Wright State, where he also built a large team, and a number of other places. So he has quite a bit of experience. He's also quite successful at bringing in funding from NIH. He has numerous NIH grants and a lot of really nice work in that space. He's graduated many students that have gone on to R1 universities for faculty positions in various places. And today's talk is this leadership and research ecosystem talk. Tomorrow he'll be giving a little bit more research-oriented talk on campus. That one will also be on campus.
Actually, I have enough time that I'm going to cover summary of the second talk also.
Oh, excellent, yeah. Great. So I'm going to turn it over to Amit. So
yeah, thank you. I've been here a long time ago, many years ago. It so happens that my first project in AI was in this area. There was Unisys Systems Development Corporation that Unisys bought in Santa Monica. And there I got a chance to lead a $1.6 million DARPA project on AI database integration. So in those days, we had this interpretive style prologue to compile style LDL kind of systems implemented, and data would be in memory. Now, how do you connect that with the databases? So that was a project that we had called Bridging AI and Database Divide or something like that. So we are here, and then Unisys sold off that place because real estate was very high, fetched them good money. Okay, so I'll share this talk where I'm discussing my experience in building research organizations and the kind of research that has been done, and then I will switch over to the parts of the technical and we'll spend an hour with here and a little longer if you want, that's fine. But part of the to give you enough sense of the particular areas where we believe we are doing world-class work. So building an organization involves a whole bunch of stuff. You have to have a vision in the sense that you have to have a sense of where you want to specialize and make your mark. You can't be doing everything, and you want to be good at something, and you want to be there before others are. So almost, if I were to say I have had success, a key reason for that has been that we have been 1 or 2 steps ahead of the game. Now, interesting, in my background involves working for 3 companies. That included creation of, I was in the research part of those companies. Research labs were, very, I think, attractive in mid-85 when I graduated. So I was at Honeywell, Unisys Research, and then Bell Labs kind of thing. And there I had to also 2 commercial products, serious products actually. Then I went to academia, 94, and I built 3 organizations. All my experience were of the kind where there was no presence in the area of my recruiting. So I had to, but they wanted to build that thing. So for example, my last position is at University of South Carolina, they had chosen to build a university-wide AI institute. This was a university-wide kind of competition for building centers of excellence. The dean, I worked with the dean, and then hi, Greta. And then we made the proposal, and that was awarded. They got the first ranking, and we built that involved hiring the faculty from because there wasn't much AI presence on the campus in the computer science either, not at the world class level that we would need. And then within 4 years, we had grown to nearly 50 researchers, and that includes these 7 faculty, but also 35 PhD students, almost all funded fully as GRAs, right? So that's quite a bit of building an organization. But we had to have, again, areas in AI that we aspired to lead, and then I think we led also. I'll discuss that in the second part of my part of my presentation. You have to build collaborative teams. So because it was a university-wide AI institute, from the very beginning, we had to we wanted to do collaborative interdisciplinary AI and collaborative work with different disciplines. So I had research projects mostly funded with at least 10 or a majority of the colleges and schools on the campus. Right? I'll mention some of them as we go along. A talent. So you have to recruit both faculty and students. The president of the university, previous university said that the quality of faculty that I was able to attract to join the center or institute were far unlike any that they had. So I had a disadvantage in the sense that I was not building anything like at Stanford or University of Southern California. I was building it was a tier 1 university, but nothing, but attracting the top talent there is a challenge. And when we started the AI Institute, it was 2019. There, the job situation was much better than today, and a lot of opportunities were there for all the good people, right? So we were able to bring fairly good people, and then also get exceptional students. Because one thing we had always decided, I always decided that my outcome of my from my group will be compatible. A student graduating from my team will be able to compete with anyone. So, for example, one of my all my students who have chosen to go to academia have been hired by R1 University without doing postdoc. So, and I know my colleagues at Georgia Tech and Purdue and many other places, and that's not the outcome that they've had so far. So this is very unique. But that means that wherever my incoming student is, they need to reach really very high level. I'll describe what that has meant. World-class resources, yeah, we did provide fantastic resources. I'll show that too. Outstanding student success, international collaborations, publications, high impact. You'll see some results of that. Complete funding, of course, you have to win them. And then there are other things like regional technical industry partnership. Now, that reminds me, I've done 4 startups, 3 as a founder and 1 as a co-founder. Currently, the 4th one is going on. 3 of them are AI startups, meaning AI technology-based startup. And 3 of them are based on the research done in the university, licensed, patented, and starting the company. So, and those startups have made fairly good money for the university also. We made the very first startup in Athens, Georgia, where there was not a single high-tech company ever founded. And we quickly grew to 35 people before it was acquired or merged. And so, we brought millions of dollars in local tax money and other things. Today, right now, as we speak, I work with 3-4 startups also. But again, it's not very time-consuming kind of things. Of course, when I was building startup, that was very consuming. But when you're advising, no. Economic impact and international recognition. So just the last example, in 2019, I moved with those PhD students, and that includes this tall guy is my former PhD student, alumnus visiting the campus in the first this is the second month of fall semester, first when we started the institute, and that grew to, as you can see, in this is 2023 picture, fairly good size. And so there's faculty sitting here and students and such. So this was AI Institute of South Carolina was the first university-wide AI institute in the Southeast US. There have been a number of places where they've been, well-regarded faculty in their lab. There have been some centers, but there weren't any university-wide organizations like the one we built. We have done core research, and I'll briefly talk about it. New symbolic AI is that, but we also do extensive amount of transdisciplinary and translational research. An outcome of faculty and students have been great. I'll talk about that. And I think we have put the South Carolina on world map as some of the people I would recognize. So this is the picture that shows the areas that we work in. These are the AI areas in the inner ellipse, and the outside are the collaborations that we are having. That's pretty wide, as you can see. Of course, not all of them at the same time, but it is not unusual to have 5 at the same time. So I'll briefly mention some of them later on. These are all the example of actual collaborations on the campus. So there are a number of collaborations that are outside of the campus, but these are some of the campus basic. Although this logistics, for example, was with BMW, but others were all. So leading with the vision, this is not an organized slide, but this is something for me to recall how we started, how we led some of the areas of work. And I'm only kind of starting here around 1990 and 2000. In 1999, I started my second company, which was a semantic search company. And I remember in 1990s, I had a project that became commercial product called InfoHarness, and ISI, and I think Craig and somebody else, they also had projects with their ontology and ontology-based database access kind of thing. So similar kind of things we were doing there. But this project, today knowledge graph is very popular. But here I had built, my company had built very large and comprehensive knowledge graph, and we had this extensive tooling to do so. So building knowledge, many people in AI have been hesitant to use knowledge graph over the period of time. Not recently, it has become very acceptable. Gartner put it on the map, but in the past, 10 years ago, they were pretty hesitant. We are very early, adapter, ontology, design, development, and open source, commercial, and knowledge graphs. And this was a patent in 2000. And we did semantic search, browsing, advertisement, personalization, that kind of stuff. And this was in 2000, we had a commercial product. And I can, there's an article, if you go to LinkedIn, the first article, oldest article, you'll see, I described 15 years of semantic search. This was very similar to what Google came out in their semantic search in year 2012 and 13. They talked about things, not strings, but we were doing that well, in advance. Now, at some point, we were kind of competing with Google, but we did not have a chance because Google took $25 million in investment from Sequoia. My investor from Silicon Valley was a little bit smaller and greedy, and so he said, well, valuations are going up high, so let's start with small one. And then came April 2000 when NASDAQ went down, and for 4 years no VC invested in any business model that had advertisement base. Nobody. When Google came out in 2004, and did IPO, then they started doing that. Unfortunately, that was a time when I had to build my company. So I had to pivot and become vertical, so serving a financial services market. Anyway, but there's some very interesting thing we did very early on. This graph shows that we are using both machine learning classifiers and knowledge base at the same time. So today, we talk about neurosymbolic, but meaning combination of statistical and symbolic AI. We had implemented this on a very highly scalable. On one server, we are processing 1 million pages per hour, and we are applying this kind of techniques in that. I had a paper in 2005, semantics for semantic, the implicit, meaning machine learning, the formal, meaning symbolic, and the powerful, meaning probabilistic and fuzzy. Then came, this concept of computing for human experience. Here are the people who have greatly influenced my thought process. It was whenever Bush, 1945, as we may think, McCarthy, Mark Weiser, Engelbart, Licklider, and these are the kind of people who talked about computer-human symbiosis and collaborative work and number of things of that nature. But the things that I was a very early adopter was the power of relationships. Much of the early technology was focused on IR and then keywords. Getting into the entities, relationships, and complex relationship has been something that I've been early adopter of. And the other thing is, influenced by Mark Weiser and all, building technology for, improving human experience, human life was an early thing. Another very early work, relatively early work, was this semantic, cognitive, and perceptual computing. This was before I learned about system 1 and system 2. So, but perceptual computing is system 1, and cognitive computing is system 2. And semantics was very important because you want to convert keywords and syntax into semantics so you can deal with meaningful meaning and understanding. And so this work I'm very proud of, although it's not as much known as I would have hoped it would be. And then we are very early adopter of knowledge in AI context. So there was a paper where I showed 4 applications and showed, compared to the best state of the art, how use of knowledge substantially improved the outcomes. And then, my third company was a clinical NLP company, and we built a very large knowledge graph in clinical domain, and we did very well, and that was a good exit. My last company is actually started with this treaty system where we did a spatio-temporal thematic, people content network, sentiment, emotion, intent, real-time analysis of social media content. I thought it was really. So I'll show you how that whole project was developed, and it's currently the 4th company. Health has been an area of largest source of funding. So I used to work on augmented personalized health. It was also very exciting. So research, projects. One thing that is interesting, and again, you need to use the context, not necessarily of ISI per se, but a typical department. Virtually all my projects involve real-world challenges, real-world data, interdisciplinary collaborations, research, of course, I would like to say top-notch, and real-world deployments, real-world use, measurable real-world outcomes, and sometimes commercialization. Right? So this was, for example, a project NICHD funded R01, where we worked with pediatric asthma patient. We built a kit, and we collected 29 different parameters, collecting several thousand data points per day of different kind. And we develop a digital phenotype. So you can see there is web-based pollen and temperature and all that. Then there are things that are from the devices, like spirometry or other things of that nature. You had Fitbit and other things. All of these were collected, plus clinical data and plus questionnaire to the patient. And then we have dashboard, and then we develop a digital phenotype that would tell you, help you understand what is the possible cause of for the symptoms that you're having. It could be poor air quality, it could be pollen, it could be so many other things, right? So and we consented 200 patients and had data from 150 patients. And each of them were 1 month or 3 month evaluations. So substantial, collaborative work with Dayton Children's Hospital. We have projects in smart manufacturing currently. 3 projects were funded, 2 are completed, third is going on. And there's a digital cell. We have access to the real, actual data collected on this platform, as well as a lot of other data from other sources. And you've done some very interesting work in smart manufacturing. This is a project that is pending and potentially unlikely to be funded because it is about, you can see the top. So it is racial equity, and what's happening in the funding in that area. But this is a fantastic project. A lot of preliminary work has been done with a school, with our College of Education in 2 departments, in College of Arts and Science, in Earth Science basically, and of course our AI people, and analogy-based pedagogy. So if you talk about, if you hear, Millian Michel talks about analogy and abstraction, very important components of intelligence, and that's something that current AI does not do well in. Here's a proposal done with Stanford, Berkeley, Georgia Tech, Maryland, Ohio State, HBCU, and very exciting, where the neurosymbolic AI was at the core. And we are talking about new materials, new proteins, and new drugs kind of design. Now, this proposal was kept by NISF for 9.5 months, and the program manager told me they wanted to fund, but the incremental fund did not come through. But it's just a very exciting thing. I also done, I have pending NSF AI Institute proposal that involves bringing together a very large number of people, about 20 faculty and such, and extensive effort. So done my share of, good size proposals, and then several of them. AI, healthcare has been with me since early 1990s. One of the first project was with University of Medical College of Georgia, MCG, and then it has just continued throughout. So they span clinical assessment, self-management of patient engagement and empowerment, like giving devices, and that the asthma project we talked about is along that line. Over the period of time we have done, and so that theme I have called augmented personalized health. And then we have involved multiple medical use cases. You can read many of these things over the period of time, and to a small extent intervention. There are a lot of clinical issues involved here, so that the deployments are very challenging. So that's why I said small amount. And within the AI technologies, and other big data and mHealth and other technologies, there have been a whole bunch of things that we worked on. You can see in the bullet list there. Now, this was the kind of a blueprint for going after a large program grant that I have not yet done, but something that I would like to do. This is a very old slide, but it just said that my funding came from a rather diverse source. So while I was at Wright State University, where we built the largest research center in the history of the university, the Noesis Center, we had, you can see, fairly good size, student population and funding from diverse sources. in my case, because I had this opportunity to build from the scratch, building, faculty excellence. I don't want to talk about myself, but bringing in young faculty and making them successful has been part of our strategy, and we've done that very well. Here is a faculty that we hired, assistant professor. Within 3 years, he had this result as a PI, more than $1 million funding. And you can see quite a bit of good collaborations. Another faculty, he also has, multiple NSF grants and more than $1 million funding in 3 years. Right. So, and again, diverse research portfolio. This shows you, while I was at the, while we were colleagues, the faculty, productivity went very high. You can see that with that is, so generally I promised and delivered about 150 to 250% productivity compared to any comparable in the college or department. Students have been, the biggest the measure for me has been the student success, for my own success. And I have some principles: learning how to learn, focus rather than learning, and then what do you have that others don't. There's a movie, 2013, black and white movie from The Artist, a French movie that won Oscar. And the young artist goes to a seasoned actor and say, "How can I get plum roles?" And that guy says, "Well, what is it that you have that others don't? All the other people who have learned, how to act and so on and so forth." That's something you have to work with each student individually and make that profile. My recruitment model has been very unique now, and it has been fairly refined. Lot of students work with us as interns before I would ever recruit them. So, 2023, the AI Institute had 100 plus publications, and my team had 40 plus. Half of them had interns working from them. Because suppose I have to do, evaluation involving 15 large language models. It's a heck of a lot of work going on to do that, right? And publishing top conferences require massive amount of evaluations these days. So, and I had some other interesting things. For example, somebody she gave $100,000 in gift so that I could bring in students, females, who want to do PhD in AI. So I was able to bring them in and give them the hands-on experience that often led to fantastic publications and other development. The last one got a fully paid offer from a fellowship from USC, this USC. She got fully paid also from Washington, Washington, and also from MIT Media Labs. So, this has been extremely successful in taking the students and, raw students and get them into, they need to be ambitious. This is a very old slide, but this remains, they all have done great job, in first job, internships, publications, and won awards and other things. For example, Manas had more than 1,000 citations before he graduated. Now in 3 years, he has about 3,000 citations. So that shows, quality of work he did. And he had, 40 plus publications, gave a lot of tutorials and talks, organized workshops, won Best Paper Awards, got a small research grant, but in his own name as a PI before he graduated. I have another one who is graduating now. He only got offer from Tier R1 University, and a startup gave him a letter saying, "I will add $50,000 to your startup fund." So that is an example of what is it that you have that others don't, and that's why they will be successful. I mean, this I'm sure USC students are doing as good or here, very, very, very strong alumni community. They are, so my organization is called Gurulkul, and some of you may be aware of Gurukul system in ancient India, and it's a, so you're not a father, but you're an academic father, and that you invest a whole lot in them, and the students remain in touch 20 years, 30 years after um, they graduate. Um, we try to combine education, research, and innovations. Um, this is an example of how I built a company. This is 2016 election, real-time monitoring and analysis of um, all the social media data coming in and talking about what is the public perception, sentiment, emotion, volume, many other things like that. And then until 2016, so from 2012 US election, 2014 Brexit, I predicted before it before the vote came out. 2016 election, I said Clinton is not winning, and so I had 100% curious sort of winning record on that. After that, I had to give up, and one of the reason was this company was this technology was taken to start a company, and that was not in this market. But the other one is that the amount of fake news and misinformation and bots has made that strategy unworkable anymore. So in building this company, though, you can see the kind of things happen. There were NSF awards, research awards, main research funding. There was in NIH funding. Then I got PFI, ICOR funding, where you do market study. And then, I have PFIR for technology scaling up. And then I licensed the technology. So lot of industry partners in what we do, small and large. Some of them do cash donations to my research. I've had some, I've been advocating building research universities in India. I had meeting with the Prime Minister of India recently, and I gave a, but I gave advice on how to make a unique value proposition again, vis-a-vis cost of building a very large language model. Here's an interesting thing: building a brand. This is in 3 years after I started ASC. You can see how well we were, followed, and we sorry to say, we even beat ISI on this one. But point here is that we must be doing something right where so many people want to follow. Of course, HCI Stanford, of course, beats everybody by far. But we build a lot of our online presence, lectures, and many other things. Everything online, documents, very widely. In this is old 2015, but we were once ranked, shared 7th position in the world in the area of World Wide Web on Microsoft Academic Search. And here is my student at 5th location. That was pretty unusual, right? In the world. And at USC, we are the technology. The university gives this out to everybody. You can see, main technical organization. We do a lot of community things also. Here, I funded a robotics team that won. Built academic programs and such. This latest is AI for All course. So I've been conducting a summer camp for high school students, and that has been very successful. And using that content, we started a AI for All course for the whole campus. Our facilities have been world class. We've built fantastic collaborative environments, as you can see here. This is so that this is at Southern California. This is at South Carolina. This is at Wright State. Um, and yeah, so that's basically um, the any question at this point before I kind of switch for my remaining time to give you a glimpse of what um, kind of research we are doing. And
So you touched on a lot of different areas. I'm sort of curious if you think there's certain key things that are critical for building a large successful group like that.
Well, first, being ahead, just like for startup also, you're a big established company, you have to be in a unique area and solving a unique problem. I think my bets in the areas like role of knowledge and or statistical and symbolic AI together, and and then now neurosymbolic. I just got you and I both got email, and Yolanda also got email about from AAAI, the fellows, and they said they want to discuss future AI things. And guess what? What is the first item noted there? They give three examples. First is neurosymbolic. I started doing neurosymbolic. So knowledge infused learning in 2015-16 in this form. Uh, Both pre-LLMs and post-LLMs. And we're there well before others were. And there's a part of neurosymbolic that I think we lead. We've done most in knowledge graph-centric neurosymbolic, not as much in the logic-centric neurosymbolic. So those kind of bets have been very, very valuable. The other thing is I showed you through that timeline of research, very timely research, all the way to commercializations through a whole bunch of things that it takes to do that. And then at all these times, training your students to do unusual things. I mean, you take student from anywhere. I mean, when Satya Sahu got offer from, and I was mentioning to somebody from Case Western, they had 400 applicants, including postdoc from Stanford and PhD from CMU and other places. And here, a student of mine from Tier 2 university gets the offer. And he's tenured professor now. Building, so building that group, whatever it takes, also the people skill, meaning building team, and that performs very well, having them motivated, having them tied to the, all my PhD students do 3 internships, and most of the time with very good places. Yeah, they will go to IBM Research, they will go to Bosch, they will go to Amazon, they will go to whatever. It's all these places, and that experience, or there are other prestigious internships, fellowships, and all that. And that gives them an experience in doing the PhD and matures them so much more compared to somebody who does routine amount of work. So I think these are all the people, vision, and technology associated with them, and execution. All of these are very critical, similar to building a startup. So I showed this already. There are 2 themes. Well, we may work on more, but 2 that I want to emphasize right now, and 2 kind of things we do. One is we deal with the challenges of generative AI. And generative AI has been highly successful. There's so much, ChatGPT, everybody uses it, and yet there are massive problems. And so what are they, and how we mitigate them, those problems? That's one. And these are the terms that we have coined, or at least written about first: civilizing and humanizing AI. And the second is building AI that is intelligent, trustworthy, robust, and trustworthy. And most recent is we are building something very exciting, and always ahead of the game. Meaning, by the time, while everybody still invests in LLMs, we already moved on to this so-called custom, compact, agile, composite AI systems. And I'll briefly give you an idea of what those things are. And the idea is, and so we're working on this before Gartner came out about 5 weeks ago. Gartner said that LLM can solve only 10% or 5 to 10% of the enterprise problem. And these are typically content and creative work that people do at companies. But there is 90% of other work where you have to take decisions, where you have to take actions, and where you can't deal with hallucination or at least all these inaccuracies and wrong information or wrong guidance, right? Healthcare problem, for example, you can't tolerate unsafe environment. So um, uh, so we are building a platform on which, with data, knowledge, and human expertise, you can come out with highly targeted but high quality, um, uh, very high quality models. And not only models, but the whole ecosystem around that. Given the time, I'll describe that, and I'll certainly describe that a lot more tomorrow. The in these challenges with generative AI detectability, is it AI hallucination, misinformation, toxicity? These are the problems that we work on, and use of knowledge has become critical in how we mitigate those problems. This is from a book, Gary Marcus. And today, AI is creating so many problems that then AI is expected to solve. I had a fireside chat at this big convention, and we discussed this kind of stuff. AI is creating so many problems, and the content editors who have to fight that with AI also. That also with AI. So one of the challenges is it AI or human? This is a paper got best paper awarded EMLLP, and we demonstrated the difficulty in being able to say whether the content is AI generated or human generated, and develop variety of ways of measuring it, and so on and so forth. There are many ways you can do paraphrasing. This shows kind of visual paraphrase, and that's just not possible to currently detect easily, or in fact. So these are the many challenges around that. Hallucination has been big area of our work, and rather we've been very early, first two people probably to talk about that, and you can get these models to generate all kinds of text that incident that never happened, that Kamala Harris and Elon Musk never married, or Pfizer CEO never had said something about that vaccine. So many challenges are there. We came up with, we defined this taxonomy and evaluated in many different ways. Hallucination, why it occurs, what kind of hallucinations are there, with different classes of models and such. This was there was a big coverage, of our work in WAPO, and also in the Nature piece. Our hallucination vulnerability index was very prominently covered. There's work on visual hallucination that's going on. Misinformation is another major problem. And let me just jump to, we will have fourth at AAAI, fourth workshop on Defectify. Very large resources we have created and have made available to the community. So here's an example. This guy claims that Michael Jordan, Magic Johnson came to donate the blood. Just based on this text, it's very hard unless you have additional knowledge. So we have built a tool that automatically asks these questions and gets the answer: who claims, what claims, when claims, where claims, why claims, and to what will take fact checker many hours, significantly reduce their job to help them call. And then if you analyze this particular problem, you have to have knowledge that Magic Johnson is HIV positive, that HIV positive cannot donate blood, right? So these are all you capture in these knowledge graphs. And with that kind of stuff, you have prayer of identifying this as a misinformation or fake news. We have a NSF project. This is about preventing or reducing the harmful images generated by visual language models. So here something about Muslims or something about blacks, and we are developing techniques to essentially uh, work with the the DPO based process to delineate the parameter space that deals with harmful and non-harmful images. And so if you give this query, you'll get this kind of image, but then by sanitizing it, you can get image that is not harmful. Um, um, the second one is on neurosymbolic. You all know enough about LLMs, but there was an analysis of 1 million ChatGPT, and basically these were the top use cases you can see here on the left-hand side. Another one also said that most of the use cases were in coding and creative content creation. But this is something very interesting that uh, when it comes to decision support assistance, planning, causality, reasoning, these models don't do well at all. Um, um, Darren Asimoglu, who got Nobel Prize who shared Nobel Prize this year, also had a statement as to that. He also talked about AI can solve only very limited number of problems, and there's a lot of thing written about it. I'll pass that. But basically, relatively long time ago, DARPA already had said, yeah, symbolic AI, statistic AI, well, the next thing would be new symbolic kind. They did not use that word, but similar. So to give you an intuition, so my hypothesis is that really, I mean, our human brain, continuously do system 1 and system 2 processing. And I mentioned my cognitive and perceptual and cognitive computing aspects of it that connected by semantics. So um, in to make an AI system better and stronger and robust and intelligent, you need knowledge at all different levels. So I had a paper, duality of data and knowledge across the 3 waves of AI. And think about it. You are listening to me right now, but while you listen to me or while you read any text here, you are using your lexical knowledge, you are using your linguistic knowledge, you are using your common sense knowledge, you have a lot of world model and broad knowledge, and you have domain specific knowledge. All of these are being used by your brain. That's when you are able to actually understand what I'm saying, not just process but understand, right? So that we really need to, how do you bring in knowledge is very important. Here is a piece that we just written. Moshe Vardi had asked me to write something, so I just completed it. It's not yet published. But we talk about custom, compact, composite AI systems. And what do they mean? So here is a, monolithic AI, compound AI, agentic AI, co-pilots, and then the next generation of system they're building. And one of the way we tend to conduct this kind of work is, this kind of research is by often finding real world applications. So we have two very comprehensive and complex applications that really drive, I'll give you a glimpse of them, this issue. I'm going to pass, I have a little time here, but there is increasing evidence that the knowledge can be game changer. So medical diagnosis, there's an example where the accuracy went up substantially after using medical knowledge, as well as you started getting explainability. In question answering in insurance database, again, the performance was unacceptable with GPT-3 and 4. But with knowledge graph, you really made it far better. So there's a broad variety of examples that are coming out. And what we are doing is combine neural networks, pattern learning, plus symbolic reasoning, structured knowledge. Right? And there are two primary forms that we see now. There's another called, third one is also physics-based symbolic. I won't talk about it. That's just not pursued much. But logic-based integration and knowledge graph-based hybridization. And we pursue, and we are, I think, a leader in this particular one. We have, 25 publications in this area. And I currently am working on and showing that to build intelligent, robust, and trustworthy AI, this style of processing is very important. You see this very interesting, picture here, and I talk about variety of things that are necessary for making AI intelligent, robust, and trustworthy. So, you can see things like analogy, abstraction, causality, reasoning, planning. You can, for intelligent AI, you can see reliability, consistency, alignment, and safety, and you can see explainability, attribution, and grounding, right? All of these are very, very important requirements, as I see, for building the enterprise class AI system on which you can rely to make decisions and take actions. And coming up with these two has been, and we have a paper that discusses broad variety of approaches people have tried, so the idea here, and then we discuss different ways of connecting shallow infusion, take knowledge and throw it into the embedding space, semi-deep infusion, and then deep infusion. So different ways. And now we are working on the fourth one called knowledge elicitation. So extracting the knowledge out of the statistical AI, out of the neural networks, and aligning with the knowledge. So the variety of facts. So there is a, and we've done the work both pre-LLM and post-LLM context. And now we are increasingly making it part of our compact custom models. So here in the bottom, you'll see that there is a matrix based on embedding knowledge semantics encoder, and that along with the other metrics, for the statistical processing, can improve the results. You were able to kind of really understand all these terms and organize them correctly as to which are synonyms, which are not. So, and we also, one of these results shows that our result on the small model, TDLR small, are comparable to large statistical model, right? So knowledge can also complement and make your computation very efficient.
We're coming up on an hour, so.
Okay, so I guess I'm just going to jump with. Basically, there is work in each of this area: abstraction, analogy, reasoning, grounding, causality, and so on and so forth. But I will just jump to, this some very exciting thing. This safety. We have an NSF-funded project on safety. And such, but let me jump to autonomous vehicle. This is a platform we are building to be able to train model from scratch. I'm very excited about that. Let me show you just now, less than 2 minutes videos. MTSS is a three. Why are there two? Let me see if this will work. Continuous.
Audio on.
Yeah, because he's on the Zoom with audio on, because he needed it to talk. But if he goes into the Zoom with no audio, then it won't.
I think if
display.
I can, I'll try one. If I can turn off the.
Send us a link.
But this mic is off, right?
Yeah, even if the mic is off, the problem is it puts the audio through twice for some reason.
Okay. Anyway, so let me just describe very briefly. Um, uh, in fact, I'll just go to the slide and show. So these are, fairly exciting and comprehensive application. But in this application, so first of all, MTSS is a state law for school behavioral mental health. And it was passed in South Carolina at 2018, and it is also a law in 80% of the states in US. And we work with School of Behavioral Mental Health, folks, researchers, and we are building this application. They have years of collected data, so that is a fantastic thing we have, and that they have access to actual people that work with the school to supply this thing. But currently, there is no technological support; it's all manual. So we are building this application. The important thing from AI perspective is that you have, what I believe in is that AI can't solve the problem. Humans can use AI to solve the problems. And here you have different health workers. You have school counselor, you have district counselor, you have administrator, you have nurse, and you have clinician. And that each of the, so you're building co-pilots to serve each of them. And so you have to align co-pilots to serve these humans and their roles, right? And so that is a very exciting work to be done. Of course, it requires a lot of safety, a lot of evaluations, a lot of verification, and it also involves variety of reasoning. You can see abductive, deductive, other forms of reasoning that are necessary to support this kind of thing. So this is MTSS. Another very exciting application is food computation. And here, it's a very complex domain. Food is very challenging and complex, but everybody is interested in that. So you need procedural representation for recipe. You need ingredient cooking actions, in multiple contexts. You need multiple information of recipe, images, and text. You have user level expectation, and you need knowledge of disease specific. Suppose you want to use this application for managing your diabetes, then you need a variety of knowledge about that. So you can see that this involves very, I'm talking and, okay.
We need a wrap up.
Okay,
Yeah, so I have a question.
go ahead.
Can you talk a little bit about the research infrastructure, the kinds of systems that you need and engineering to support this research? Test
I
bed?
mean, we have our own GPU cluster, and recently we had won a $1 million infrastructure grant. So we got
So you got a $1 million infrastructure grant from the government or
from the government. And then in my startup, when I built this, there also we had some funding. So we use that kind of stuff. But we still are not going to invest $6 million, $10 million to create large language models. But you might have noticed that we are building, for example, I have a collaboration with the startup, and they're sending me the devices, and we are creating local LLMs for them. I think that very soon, much of the emphasis in AI is going to move away from these large language models and such, and to the highly custom, what I call custom, compact, agile, neurosymbolic AI models.
And where do you host your GPUs, or does the campus provide you a colo facility of some sort?
Campus is managing, our research computing infrastructure is managing.
So then you don't have to have the staff to manage it. They manage it.
I mean, I had that in my previous place. I had a staff, and we manage our own cluster. But that is a lot of cost.
Yeah.
And we are in here, university was able to provide us that.
And what about NSF's NAIR? The AI research infrastructure provided by NSF.
Well, I mean, when we win, substantial size NSF grants, then that's what we will use. That's what we will do.
Thank you.
Any other questions? Great. Okay, let's thank you.